Here's problem 418. Car A leaves point O at t equals 0 and travels a quarter circle counterclockwise at 30 meters per second to point P. Car B will leave point O and travel to point P at the same speed but in a straight line. The radius of the circle is 100 meters. At what time should car B leave point O in order to arrive at point P at the same time as car A? Let's take a look at what we have here. Here's the origin of our circle. Here's a radius. And we'll have a radius this way as well. And we're going to go around this half circle like this. And that will be our distance for car A. So let's call it D sub A, going from point O to point P. Okay, well, that's 1/4 of a circle, so that distance is going to be 1/4 of the circumference of a circle, 2 pi r, and so that is going to be equal to pi times r divided by 2, which will be pi times 100 divided by 2, and that's equal to 157 meters. Sounds good. So that's the distance A, and we know that that distance should be equal to the velocity of A times the time for A. So the time for A to complete that is going to be equal to the distance divided by the velocity, which would be 157 divided by 30 meters per second, and that is 5.23 seconds. Sounds good. What about car B? Car B has this situation. We're looking at a isosceles triangle, radius r here, which is 100 meters. And then we have another side here, which is also 100 meters. And the path for B is going to be a straight line like that. So the distance for B is that hypotenuse of that right triangle. So for B, distance B is going to equal r squared plus r squared square root, which would be the square root of 2 times r, and that's going to be equal to the square root of 2 times 100, which would be 141.4 meters. The time for B to complete that will be equal to the distance for B divided by the velocity of B. So that would be 141.4 divided by 30, and that is equal to 4.71 seconds. So car B only needs 4.71 seconds to complete the trip. Car A needs 5.23 seconds. The difference is how much lead time car B can give to car A. So the time we're talking about is going to be equal to time A minus time B. 5.23 seconds minus 4.71 seconds is 0.52 seconds, give or take 1/100 of a second or so. So car B will wait 0.52 seconds and then take off, and will arrive at point P at the same time as car A after 0.52 seconds.